Hello, this is Emad Mirabi. I'm going to teach and solve some practice problems about quantitative reasoning, the problems which can be found in entrance exam of school or university or usually in math competitions. Okay, so here is the first question. We have painted the faces of a cube with yellow, green, and pink colors, so that two opposite faces are of different colors. Which shape cannot be the expanded of this cube? Okay, we know that a cube is composed of 6 squares, so all of these shapes can be the expanded shape of a cube, because if we roll down these four, these four will be the lateral surface, and then these two squares will be the bottom and top of the cube, or front and back of the cube. Okay, so it's clear that in this shape, for example, this I mark the opposite faces with the same color, with the same shape. So it's clear that these are the opposite faces. So opposite faces here are of different color. It's okay. Here they are opposite faces, and they are opposite faces here. Okay, so everything matches and everything is okay. And then let me see the other one. Again, we roll down these four. This make the lateral surface, and these two make the opposite faces of top and bottom. This is okay again. So here is again are of different color. These are again of different color. These are of different color. Everything is okay here. In this shape, these are opposite faces which are of different color again. These are opposite faces again which are of different color. But in this shape, and these are opposite faces but the same color. So the choice which should be chosen is this one, because the question says which shape cannot be the expanded of this cube. Okay, because the opposite faces are of the same color here. Okay, another type of question which can be found in these type of questions, quantitative reasoning questions, is alphanumeric problems. In these problems, every letter means it's a digit. So different letters means different digits. So for example, this is a 2-digit number, AB, and BA is a 2-digit number, and the sum of these 2-digit numbers has become a 3-digit number. Now the question says, what is C, what is A plus B, and what is E? It's important for these questions that we understand that, okay, so for example, every letter is representing a digit, not a number. For example, A cannot be 10 or 11. A can be only 0, 1 up until 9. Okay, so because the sum of two-digit numbers has become a 3-digit number, C must be 1, because it cannot be any other way, because 98, for example, is the greatest number here, and 89, it cannot exceed 100 and something, and never it can be 200 or something. So 100 is for sure, so C is definitely 1. So let me replace these two with 1. So 1 and E. Okay, so now we've got B plus A is either 1 or 11. If B plus A is 1, here we have B plus A again, and it won't make a 3-digit number. So B plus A should be 11. b plus a should be 11. So 1 goes here, 1 goes to the tens digit, and then 1 plus a plus b is 11, 1 plus 11 is 12, so e is 2. Okay, so we solved this problem, which was not very difficult. We only needed to know that if the sum of two-digit number is a three-digit number, then the hundredths digit must be 1. Here's another problem. The sum of two three-digit number has become a four-digit number. Here again, we can understand that from the beginning. We can say that, okay, so d must be 1 because there's no other digits. No other digit is possible. So let me replace everything with 1. So 1111 is the sum of these two three-digit numbers. And then c plus a is either 1 or 11. Because we have c plus a here again, it cannot be 1, because if c plus a is 1, the sum of these two three-digit numbers wouldn't make a four-digit number. It would be a three-digit number again. So we understand that a plus c must be 11. Okay, so a plus c is 11. 1 goes here, 1 goes to the tens digit, and then 1 plus 2b makes either 1 or 11 again. If this sum is 11, 1 goes here, 1 goes up, and then 1 plus 11 would be 12, which makes it incorrect. So 1 plus 2b here must be 1. 1 plus 2b must be 1, so b must be 0. B must be 0. Here it makes 1 here, and then a plus c is 11, so we write 11 here. That makes this question correctly solved. Okay, it's enough for here.